Hello everyone, welcome back to our tutorial involving volume and surface area of pyramids, cones and spheres. Okay, so what we have in front is a solid hemisphere of diameter 12 cm with a hollow part in the form of an inverted cone ABC with diameter 4 cm. So given that the volume of cone is 1 over 18 of the volume of the hemisphere, show that the height of cone is 6 cm. Okay, so this itself tells us that we need to form an equation. Okay, so volume of cone, how is it equals to the volume of hemisphere? They are not equal, but for them to be equal, you need to times a factor of 1 over 18 as per the question here. Okay, volume of cone is 1 over 18 of the volume of hemisphere. So this is the first important part in you forming your equation. Then the rest is filling in the numbers according to the formula. Okay, so volume of cone is 1/3 times by pi r square times by height, and then volume of hemisphere is, in this case, 1 over 18 is the factor, times by hemisphere is half of a sphere. So half times by 4/3 pi r cube. Okay, so all these are constant. 1 over 18 is constant. Half is because it's a hemisphere. And 4/3 pi r cube is the volume of a sphere. So now we need to fill in our values accordingly. Alright, so 1/3 times by pi. The radius of our cone is 2 cm, not 4 cm, right? Okay, this is 2 cm times by h is our objective. So let me put it in red. Next, volume of hemisphere is, in this case, 1 over 18 times by half times by 4/3 times by pi. The radius of our hemisphere is 12 divided by 2, which is 6 cube. Okay, so this one is 6 cube. So from here is quite simple. We can just cancel off our pi, so we just deal with all these integers. Okay, so in this case we have 4/3 h is equals to, we can simplify this, right? Divided by 2, and this is 2, this one is equals to 9 here. So we have 216 over 27. So h is equals to, using your calculator, 216 divided by 27, and then you need to multiply by 3/4, and we get h equals to 6. Okay, and put a shown in at your answer. Okay, so the height of pyramid is equals to 6 cm and you're shown. Okay, the next part, let's look at this question. Calculate the curved surface area of the cone. The curved surface area of cone. So let's look at our cone here. In blue, the curved surface area of the cone is obtained by taking pi rl. Okay, pi times by radius. We know the radius is equals to 2 cm. L is our slant height. Okay, this is our L. So again, when we deal with cone, we need to remember that we can apply our Pythagoras theorem. So as per my red color triangle there. Okay, so we have at the side here, the radius is equals to 2 centimeters. The height of the pyramid is found to be 6 cm, correct? So we just need to find our slant height. Okay, so earlier on, this is part A. So part B, finding our slant height first. So 6 square plus 2 square equals to L square. So basically, L is simply the square root of 36 plus 4, correct? So it's basically square root of 40. And our slant height is simply equals to 6.3246 cm. Okay, this is our slant height. We're going to use this value to find the curved surface area of cone. So curved surface area of cone is equals to pi rl. And what we get is simply pi times by radius. In this case, the radius is 2, and the slant height is 6.3246, which is equals to 2 times pi times by 6.3246, and the answer is 39.7. Okay, this is our curved surface area. Okay, so again, we need to utilize the fact about Pythagoras theorem. We get the slant height, or we can get the height or the radius by applying Pythagoras theorem in our diagram. Okay, let's look at part C, volume of the solid. Okay, so volume of this solid is obtained by taking volume of the hemisphere minus volume of the cone. Okay, so volume of solid equals to, our volume of solid is obtained by taking the volume of hemisphere minus volume of cone. Okay, it's quite simple. So let's put in all the values. Hemisphere equals to half times by 4/3 pi r cube minus 1/3 pi r square height. Okay, so this one becomes 2/3 pi. Radius of hemisphere is equals to 6, so we got 6 cube here, minus 1/3 pi. The radius of our cone is equals to 2 cm, 2 square, and the height we will obtain is equals to 6 centimeters. Okay, so type in the numbers in our calculator. We will get 144 pi minus 8 pi. Okay, so 144 pi minus 8 pi is simply 4 equals to 427.257. So put this to 3 sec feet will be 427 cubic centimeters. This is the volume of the solid. Okay, it's quite simple. Let's look at the last part here. The solid is melted down and recast to form a square pyramid. The side of the base is 15. Calculate the height of pyramid. Okay, so there is the idea of a conservation of the volume, right? The volume of 427.257 is equal to the volume of the pyramid. Okay, so 427.257. Let's look here. 427.257. This is equals to the volume of pyramid. Volume of pyramid equals to 1/3 times by base area times by height, and that's what we need to find. So it will be in red here. Okay, so because the base area of the pyramid is squared, so 427.257 equals to 1/3 times by 15 times by 15 times by h. Okay, so h is simply 427.257 divided by 1/3 times by 15 times by 15. Okay, and your answer using your calculator, you will get 5.69676. Okay, so to 3 significant figures, it will be 5.70 centimeters. Okay, so to recap about this question from part A, we just need to remember the factor 18 has to be considered for the volume of cone to be equal to the volume of the hemisphere. Okay, so that's why we have a factor of 18 in our equation earlier on. Okay, next part, curved surface area of cone. We need to find the slant height of the cone, which is again utilizing our Pythagoras theorem. Volume of solid is simply the difference in the volume of hemisphere and the volume of the cone. And lastly, solid is melted down. Melted down and recast means the volume of the original solid is equal to the volume of the new solid. In this case, this is the volume of our solid. Okay, the volume of solid is equal to the volume of pyramid. Okay, they are the same. So we form them into an equation for us to find the height. Okay, our height of the pyramid. Okay, that's it for our example on volume surface area of pyramid cones and hemispheres. Till then, I'll see you in our next tutorial.